Hey guys, sorry I couldn't be here today. I'm at a conference right now. But this lesson is about solving linear equations. Now we've already solved a few equations when we did the word problems a few classes ago. So some of this is going to be just a little refresher, but then there are some tougher problems and some special cases that we haven't really talked about yet. And where this chapter goes after this, we'll get into quadratic equations, and then we'll get into even more tougher equations, if you will. And so this lesson is just how do you solve equations in general. We'll start off pretty basic here. Example 1, if I want to solve this equation, if you have variables on both sides, you're going to move your variables to one side. I don't need to see the minus 3x, minus 3x. I don't need to see that work. If you want to show that, that's fine. But if you can look ahead and you're like, I know I'm going to subtract 3x from both sides and get 2x, that's fine. And I know I'm going to subtract 4 from both sides and get negative 12, I'm okay with that. And then divide both sides by 2, and x equals negative 6. So I don't have to see every little step within the work. Now, one cool thing about equations, and I like to call it cool, but one cool thing is in an equation, you can actually check every single answer. In fact, when you solve an equation, think about what you are finding. And I think a lot of people don't actually think about what they just found. When you solve an equation, you are finding the number, or numbers, if there's multiple answers, that you could plug in to the original equation, where these x's are, and make the left side equal the right side. You're finding the number that satisfies the equation. And so you can actually check every single problem when you get an answer. For instance, if I plug negative 6 back in, up here I'm going to get negative 30 plus 4 equals negative 18 minus 8. So I get negative 26 equals negative 26. It satisfies the equation. I just checked and I know I have the right answer. Alright, example 2. Anytime there's parentheses, we're going to go ahead and distribute the number in front of the parentheses. So just bring down the x. One thing to keep in mind here, if this x minus 3 was in parentheses, we would be foiling or double distributing. But it's not. The only thing being multiplied in the parentheses is the negative 3. So little things like that to be careful about. So bring the x down and then distribute negative 3. So negative 3x minus 6 equals 6. So negative 2x, and add 6 to both sides, so equals 12. And then divide by negative 2. So x equals negative 6. Like I said, if you wanted to, you could take negative 6 and plug it into the original equation and check and see if you have the right answer. Never a bad idea. Alright. Example 3. So now we have fractions involved. You have two options to solve a fraction equation. There's the option that I probably wouldn't do. You could get common denominators and then combine the fractions and then solve from there. But here's the option I'm going to take. And I'm going to take this option because I know what's coming up in example 4. Okay? So in example 3, what I would do with a fraction equation is multiply everything in the equation by something that's going to eliminate your denominators. You're trying to eliminate the 3 and the 4 here. Okay? So the question you need to ask yourself is, what's the common denominator between 3 and 4? What do 3 and 4 both go into evenly? And you come up with 12. And so what we're going to do is multiply everything in the equation by 12. When I say everything, I mean the numerators times 12 times 12, and even the number on the other side. We're multiplying everything in the equation by 12. And then look what happens from here. Now we're going to reduce each fraction before we multiply. So 12 over 3 in that first fraction would reduce to 4 over 1. So you get 4x. No more fraction. In the second fraction, 12 over 4 reduces to 3, and then multiply. So you get 9x, no more fraction, equals 24. Now you have a whole new equation that'll get you the same answer as the original equation, but no fractions in it. So combine your like terms and divide by 13. And there you have it, 24/13. So again, to repeat that process, you're finding what the common denominator would be, and then multiply everything by that common denominator. So let's take a look at a little harder one with fractions. down here. All right, so my denominators, we have x minus 2, x plus 2, and x squared minus 4. And I'm trying to think about what the common denominator would be. What do they all have in common? And the first thing I would do is factor anything that factors. So like x squared minus 4 would be x plus 2, x minus 2. Okay. So I need to multiply everything by the same thing. Something that's going to eliminate all three denominators. Well, this has x minus 2, this has x plus 2, and this has both. So actually, if we multiply by both of them, x plus 2, x minus 2, we'll be able to eliminate all three denominators. Here's what this looks like. So I'm going to multiply by x plus 2, x minus 2 to all three fractions. Sorry about that. So over here, x plus 2, x minus 2. And the last one, x plus 2, x minus 2. So we're going to multiply all three fractions by x plus 2, x minus 2. Now, before we actually multiply, we're going to cancel out the denominators. So in that first fraction, the x minus 2's go away. And you get x plus 2 when you multiply. Equals, I don't know why that red line won't go away. In the second fraction, the x plus 2 goes away, and now you're left with 3 times x minus 2. If you distribute that, you get 3x minus 6. Then you bring down the minus sign, minus. And let's cancel out the last one. Well, both cancel out, that's nice, and you're left with 6x. So notice what happened here. We multiplied everything by the same thing and cancel out all three denominators, and now you're left with a normal fraction. So let's solve. So x plus 2 equals, combine like terms, 3x minus 6x is negative 3x. Add 3x to the other side, so 4x. Subtract 2 equals negative 8. You get x equals negative 2. Okay. Now, here's something that's important to point out. I said above in examples 1, 2, and 3, you're allowed to check. In fact, I would encourage you to check equations when you get an answer. There are some problems where you absolutely have to check your final answer. You absolutely have to check. And those types of problems are anytime you have a fraction in the denominator, or a variable in the denominator, sorry, or any sort of square root problem. Think back to chapter P when we talked about domain. How there was two weird types of situations. You would have restrictions if you had variables in the denominator, or if you had some sort of square root within the expression. Those are the types of problems you have to check in the end. So here's why that is. Think about what happens if we plug negative 2 into the original equation for all the x's. Here, here, and here. Think about what's going to happen. And this one up here. Look at what happens in this second fraction. If you plug negative 2 into x down there, think about what you get in the denominator. You're going to get 0 in the denominator. Anytime you have 0 in the denominator, that's bad news. So negative 2 is the only possible answer, but when you plug negative 2 back into the original equation, you get some fraction that's undefined. So negative 2 actually doesn't work. It's called an extraneous solution. It's a solution you get through manipulating the equation. In fact, negative 2 would make this equation true, but it doesn't make the original equation true. And therefore, negative 2 is the only possibility, and it doesn't work. So there's no solution to this equation. So in the end, when you get an answer, you have to check it, especially if you have a fraction equation, or some sort of square root equation, which we'll come across in a couple lessons. All right. Some other special cases. So there's a special case. Here's a couple others. Let's solve this equation like normal. For example, 5. Let's distribute the 4. So 8x plus 12 equals 8x plus 1. And let's move all our variables to one side. So subtract 8x from both sides. the 8x's go away, and you get 12 equals 1. Now think about what this means. You get 12 equals 1. We're trying to figure out what we could plug in for x at the very beginning of the problem that satisfies the equation. Well, if you notice in this problem, x goes away, and you're left with 12 equals 1. 12 is never going to equal 1. No matter what you do, you're never going to make the two sides of the equation equal. So what that means is we tried to solve this equation, but there's no solution to it. If your variables cancel out, and you get a false statement in the end, it doesn't matter what the numbers are. I mean, it could have been 100 and equals 7. It doesn't matter. But if you get a false statement, then your answer is no solution. Well, I just talked about a false statement. Let's talk about what happens if you get a true statement. So, right here, let's distribute the 2. We get 2x minus 6 equals 2x minus 6. And I always like to move my variables to one side, so I'm going to subtract 2x from both sides. And you get negative 6 equals negative 6. So again, the variable canceled out. But in this problem, we get a true statement. This is true. Negative 6 does equal negative 6. The number there is irrelevant. Whether you get 0 equals 0 or 10 equals 10 or whatever, if there's truth there, think about what this means. We could plug any number in the world in for x, and this equation is always going to be true. So our answer for this, if you think back to Algebra 1, is all real numbers. All real numbers. We could plug any number in the world in for x, and this equation is going to turn out to be true. So all real numbers would be our answer there. So there's our two special cases. If x goes away, or your variable, and you get a false statement, no solution. If you get a true statement, all real numbers. One other interesting type of problem, back in Algebra 1, you guys solved literal equations, where you had a formula and you had to get one of the letters by itself. You had to manipulate the equation with letters instead of numbers. Same idea here. Example 7 says solve the following for x. So we're trying to get x by itself, but if you look here, there's this weird ax that's kind of going to mess us up. All right? So I'm going to teach you how to do a problem like this if you want to get x alone, and there's multiple x's in it, and multiple variables. The first thing you're going to do is take anything, and I want you to listen carefully, take anything with an x and move it to one side of the equal sign. So move all your x's to one side. So you get 4x plus ax equals 5. Anything without an x, move to the other side. Okay, we can't combine those, and we're still trying to get x by itself, but think about what this lets us do. We started in our equation with 3 x's. Now we combine 2 of them, so now we have 2 x's. And think about what you could do at this point to get it down to 1x. They both have an x in it, so you can factor an x out. Right there. So we had 3 x's, we got it down to 2, now we have 1 from factoring it out. And from here, we can divide both sides by 4 plus a. So x equals 5 divided by 4 plus a. We don't know exactly what x is. I mean, it depends on what a is, but we got x by itself. There you go. So get every x to one side, factor it out, and there you go. The last thing we're going to talk about, we talked a little bit about graphing with slope-intercept form and whatnot, and I think this even came up in one of the lessons. It is an important lesson, an important topic in terms of graphing, so I want to make sure I talk about it again in case, number one, you forgot, or number two, I didn't cover it. But we can actually graph lines without finding slope. You don't need to put an equation into slope-intercept form. You can find x and y intercepts simply by plugging 0 in for the opposite letter. Meaning if you want to figure out where a graph is going to cross the x-axis, plug 0 in for y. Because on the x-axis, all the y values are 0. And if you want to find the y-intercept, plug 0 in for x. So you plug 0 into the opposite letter. So I want to take a look at that in action. Look at example 8. Find the x and y intercepts of the graph of the equation algebraically. So I also want to graph this, but I don't want to get y by itself. I want to first find the x-intercept. Where is this going to cross the x-axis? So to do that, we plug 0 where the y is. So 4x minus 5 times 0 equals 12. Well, 5 times 0, that's just 0. So 4x equals 12. So x equals 3. That means this line, when I graph it, will cross the x-axis at 3. So I'm going to draw a little coordinate plane. And I can actually put a point on the x-axis at 3. Now, if I want to find the y-intercept, plug 0 in for x. So negative 5y equals 12. Divide by negative 5. So y equals negative 2.4. So on the y-axis, we could put a point at negative 2.4, just an estimation. And we could draw our line. So we didn't actually have to find slope at all. So just another way to use solving equations to graph a line. Plug 0 in for the opposite letter and find the intercept. Alright, what you're going to do now is with a partner, so you can work with a partner on this, you're going to take the Canvas quiz that's on Canvas. You have 2 attempts at it. You probably need to do your work on a separate sheet of paper. You don't need to turn that in. But you're going to go on that Canvas quiz, answer those questions, and hopefully you get it perfect with your partner. And then you guys have an assignment to work on. See ya.